So, last class we have discussed how to solve standard LP problem, linear programming problem by using algebraic approach, and then we have considered a numerical example which we could not complete. So, we recap the example here. So, our problem is given the function which you have to minimize subject to the constraint, which is in a standard LP problems. So, what we have to do first? So, these two linear equation we have to write into matrix and vector form. That means, we have to write in A x is equal to B form. That if you look these two expression, then A matrix is 1 0 2 2 and next row is 0 1 2 minus 2 from this one, and B is 6 3. So, now we have to do this thing into a that variables we have a x 1, x 2, x 3, x 4 variables are there. So, we have to choose the which are the what is called the basic variable and which are the non basic variables. These two equations straightway they are already in canonical form. So, what that x 1, x 2 I can consider as a basic variable, and x 3 and x 4 are non basic variable. So, we have partition x 1, x 2 this and x 3, x 4. So, basic variables as we have used the standard notation x suffix b, and then non basic variable x suffix n. So, correspondingly the what is called the objective function that we will write in terms of C transpose of x, and accordingly from this expression C transpose is this one. Coefficient of x 1 is 1, coefficient of x 2 is 1, coefficient of x 5 is x 3 is 5, and coefficient of x 1 minus 1. And then we have partition this C matrix, C transpose matrix into two parts. The variables x 1, x 2, which is that means basic variable which is associated with the C transpose matrix that we have partitioned and denoted by C B transpose, and this C D transpose non basic variables associated with the non basic variables. So, with this one we have immediately that identified the B and D matrix from the matrix formed from the A matrix that we have formed. That B matrix is associated with the basic variables x 1, x 2, and D matrix associated with the non basic variables, and C B transpose which is formed from the performing index or the objective function associated with the basic variables, and C D is associated in the performing index associated with the C transpose matrix in the objective function. C D transpose is associated with the non basic variables. So, first we have to find out the that initial vertex by solution of this equation that we have derived earlier, B into D, because our A matrix is partitioned into a B into D form, x B this. Since x n is 0, so x B into B plus D into x n is equal to B small b, this is the small b. Okay. From there we got the initial solution or vertex point is 6 by 2. So, this is the initial vertex. So, our x 1 value is 6, x 2 value is 3, and that remaining two variables x 3, x 4 are the non basic variables, that is. So, this is the solution for initial vertex scenario. So, correspondingly immediately I can find out the cost function value, that is f of x value is that one. So, that value is, if I put the value of x b value C B transpose C D transpose x n is equal to 0, then I will got that objective function value is 9. Then our question comes, logically question of whether those non basic variable, if one of them is changed to a basic variables and the basic variable one of them if changed to the non basic variable, whether the objective function value will decrease or not. So, that can be tested with this vector. in the which we have derived earlier. So, you know C D transpose is this one, C D transpose, C B is transpose this one, then B inverse B is this one, that inverse is that one of this, agree. Then D is that one, you see this one, B is this one, and D here you see that is by mistake it is a minus 2, this one is minus 2. So, then D is that one. So, if you simplify this one, we got the 2 minus 1, and that associate with the non-basic variable x 3 and x 4. Now, it is clear that in the objective function which can be expressed into a two parts, one is R D transpose into x 3 x 4. You see from this expression, this negative terms, the negative value of that associated with x bar x 4. If we change this non-basic variable to a basic variable, agree, then there is a possibility to reduce the what is called function value. So, our choice will be next, our non-basic variable x 4 will be converted into a, or will be treated as a basic variable, and from x 1 and x 2, which there are two basic variables are there, out of which one we will consider the non-basic variable, that we have to decide. So, from this one we can see this one, choose x t is the what is the entered basic variable, from non-basic variable to it is entering to the basic variable x 4, and this is one associated with the largest negative, this is the important largest negative component associated with R D transpose, largest. Suppose we have a more than 2 negative numbers was there, out of this which one is largest, that you will consider as a what is called entering basic variables, because that element, if you consider the largest negative component of R D, if you consider as an basic variable, that will reduce the function value very compared to other negative values, it will reduce faster, or you can say reduced in the better way. So, this is last class we have discussed. Then we will see today that once we know that x 4 is the our non-basic variable will be changed to a basic variable, then we have to select between x 1 and x 2, which one will be the non-basic variable. So, step 3 is, so select w is equal to, that is that you define w which is associated with the non-basic variable x 4, the element associated with the non-basic variable x 4 from A matrix. See this one, our A matrix is this one, A matrix is that one, and it is x 4 is now entering as a basic variable. So, this column we will consider as a w, defined as a w. So, that is we defined as a 2 minus 2 is defined as a w, and that is corresponding, that let us call this element is w 1 and this element is w 2. Agree? So, then corresponding A x is equal to b, that equation basic set of linear equation, that b we have a 6 3, which is equal to that we denoted by b 1, that we denoted by b 2. So, now calculate the ratio b 1 by that b 1 by w 1. What is these values? Is equal to 3, and b 2 by b 2 by w 2, and this will be minus 3 by 2. Agree? So, we have to find out this ratio, and out of this we have to consider only positive one. Agree? So, our next step is to find, because this is associated with the w is associated with x 4, we have considering the basic variables. Now, we have to select from x 1 and x 2, which one is the basic, what is called which one will be non basic variables. So, this ratio that corresponding to x 1 and that corresponding to x 2, which will enter as a non basic variable. So, see this one, that we have to consider the positive quantity ratio, which one is the largest least ratio of this one, that we have to consider least ratio and positive, that corresponding variable will be considered as a non basic variable. Now, you can see also from here how we are taking this one in the day earlier also we have discussed, but if you see this expression, let us call this expression, let us call, we write the first is that expression of this one, agree. So, this one if you write it, let us see here, I am just x 2 plus x 3 minus 2 x 4 is equal to 3. But our x 3, x 4 previously it was a non basic variable, and from there we have selected the x 4 will be a basic variables. So, this value cannot be 0. So, this is remain as a non basic, this is 0. So, we have a now we have a equation x 2 is equal to minus 2 x 4 is equal to 3. Another equation, from the first equation you see that x 1 plus 2 x 2 3 minus plus 2 x 4 is equal to 6, and this is now we have considered is a basic variable, non basic variable changed to a basic variable, and this is non basic variable. So, we have a expression for x 1 plus 2 x 4 is equal to 6. Now, look, out of these two variables x 1, if you consider that x 2 is the non basic variable, then x 4 value is coming negative. So, it cannot, because x 4 is greater than 0. Since x 4 is greater than 2, so x 2 cannot enter as a non basic variable. Now, in this case that is x 2, if it is a non basic variables, x 2 if a non basic, that x 2 is 0, the x 4 is equal to negative quantity. So, this cannot be a non basic variable. Suppose this is a non basic variable, x 1 is treated as a non basic variable, then x 4 value is coming to 6 by 2 is equal to 3. That what we are checking the ratios, see B 1 by W 1, B 1 by B is 6 by W 1 is 2. So, this that way we are checking. So, now we have selected x 1 is living variable, being the one corresponding to the least positive ratio among the ones we would selected ratio with positive values, with positive value. So, this the next step is step 4. So, now we have selected, if you recollect that x 1 and x 3 are non basic variable, next iteration is non basic variable, and x 2 and x 4 is the basic variables. So, you have to check the stopping criteria, check the stopping criterion. So, what is this one? If you remember, x 2 and x 4 is the basic variable, x 3 and x 1 are non basic variables. So, we have identified. So, now once again you from A x is equal to b. Now, we can identify from A x is equal to b. So, we have a matrix A x is equal to b. Identify which variables are basic variables and non basic variables. We have seen x 1 and x 4 are the basic variables, and correspondingly we can write that what is called our B matrix from A matrix. B is in now in this case is 0, 2, 1, minus 2. So, this corresponding to x 1 column, this corresponding to x 2. This is we formed from A matrix. A matrix you have a 4 columns, and the columns associated with x 1 I have written here, because that is the basic variables. Column x associated with the x 4, this is x 4 is the basic variable, that column I have written. Then D from the A matrix, column associated with the non basic variables, that means x 2. Basic variable, sorry, this is the 2, this is the basic variables are x 2 and x 4, and this is the non basic variables is what, x 1 and x 3. So, column associated with x 1 in matrix A are 1, 0, and this is the non basic variable. Column associated in A matrix associated with the non basic variable x 3 is 2, 0. So, once again I repeat, since x 2, x 4 are the basic variable from A matrix, I am picking up the columns associated with the basic variables, that means x 2 and x 4 from A matrix. Similarly, non basic variable x 3 and x 1, x 3 from the matrix A, I am picked up the D matrix. So, you know A, D. Correspondingly, the performance objective function, I found out the C B transpose, that is corresponding to the variable non basic variables associated in the objective function 1 minus 1, that is x 2, x 4, and C D transpose, that is associated with 1, 5, that is x 1, x 3. See this one, if you look at this one, that this x 1 and x 3 under non basic variable, the coefficient associated were 1 and 5. So, I have written 1, 5, and the basic variable x 2 and x 4, the coefficient associated with this one is 1 and minus 1. When you have considered this in matrix, what is a vector form, vector notation form this, and C transpose is split up into C B transpose and C D. So, that is what we have here. Once you have written this one and B is equal to 6, 3, immediately I can find out that x into x b, b is equal to your B. So, therefore, x b is equal to B transpose B inverse, not transpose, into 6, 3. B inverse is what? B is that one, 0, 1, 2, minus 2 whole inverse 6, 3. So, if you do the inverse of this one, you will get this value after multiplication everything, you will get 9, 3. So, that corresponding value is, this is corresponding to x 2 and this is corresponding to x 4. The way we have partition x, you see x b, x we have partition into a x b, x d or x n, we have partition, that way x b is equal to x. So, our basic variables are x 2 and x 4. So, you got this one. Next, once you got this one, that our basic variable, then you have to find out the objective function value, whether the function value is reduced or not, but in true sense is not necessary. So, you have to check the what is called. So, our new corner point, if you see our new corner point or vertex is what? What is our x 1? X 1 is entered as a, if you see the x 1 is a non basic variables and x 3 is a non basic variables. So, our new corner vector is 0, then x 2 value I give basic variable x 2 value is 9, then x 3 value is your 0 with a non basic variable and x 3 value we got it 3. Agree? That is, it's the x 3 value we got it 3. So, here the x 3 x 4 value we got it 3. So, this is the new corner variable. So, now we have to see the check associated cost function value. So, we know f of x, if you recollect, C b transpose x b plus C d transpose x d. Agree? So, this notation I have written now small x, you can write it small x b, this is small x b and this is small. Throughout the text keep it that x small. So, so put the value of C b. C b means what? The coefficient associated with the basic variables in the objective function. So, that value is 1 minus 1 C b transpose, then it is a x 2 and x 4, then C d is your 1 5, then x 3, this is x 1 and x 3, x 1 and x 3, and that value is 0, this value is 0 and this value you got it 9 and this value is 3. So, if you do this one, that is 9 minus 3 is equal to 6. You see that C b value, C d value, I just put it in the objective function this. So, again what you have to check the what is called your stopping criteria, that you see the check the stopping criteria. Next, check the step 4, not step 4, this step 5. Step 5, check the stopping criteria. What is the stopping criteria? Again you find out R d transpose. Last example is see R d transpose. So, what is the R d? C d transpose minus C b transpose B inverse D. You put the value of C d transpose 1 5, then C b 1 minus 1, then B inverse value I am taking the inverse of this one 0 1 1 half 0, this is the B inverse, then your D is 0 1 0 2 1, D value you see it, the D value you got it. So, now d value what we got it, just see, that is corresponding to x 1 and x 3. What is x 1 and x 3? This x 1 and x 3, x 1 and x 3. So, this 1 2 1. So, this value is 1, not this value is 1. So, if you see this expression A matrix 1 0 2 1. So, this is 2 1, and if you compute this one, ultimately you will get half 3, and that corresponding to x 1 and that corresponding to x 3, which are non-basic variables, and see the non-basic variables are positive. So, there is no negative term associated in the R D transform there. So, it indicates there is further not possible to reduce the value of the objective function. So, our objective function value will remain same as earlier. That means, since R D transpose is greater than equal to 0, this indicates no further reduction in cost function is possible. So, our optimum value of the function as we got in the last stage, that is this one, optimum value of the function what we got it, that will be the optimum value function at the vertex. So, our optimal extreme point is 0 9 0 3, and the corresponding cost function value is 6. So, this is the solution of this one. So, basically first you have to identify the basic variables and non-basic variables, then you compute the what is called new solution or vertex of this one. Once you find out the vertex, then you compute the what is the value of the objective function value, and check the what is called further iteration is required or not by computing R D transpose of this one. Once you identify B, D, C B, C D, then you can compute that one. If the elements of R D is containing the negative terms, then take the largest negative one, that is which element having the largest negative element, that one will be the corresponding what is called non-basic variable to basic variables. Agree? So, this is the problem with let us see an example. With this example, we have shown how to sort out or how to solve the problems. And graphically, we will see now characteristics of this solution. So, minimize f of x is equal to, let us call our objective function is given 990 into x 1, 900 x 2, then 5250. This is our objective function, and subject to g 1 of x is equal to 0.4 x 1 plus 0.6 x 2 is less than equal to 8.5. Then g 2 of x is equal to 3 x 1 minus x 2, then 25. G 3 of x is equal to 3 x 1 plus 6 x 2 less than equal to 7. So, one can easily form this is you can convert first you convert the what is called standard LP problem. So, standard LP problem. So, 0.4 x 1 plus 0.6 x 2 plus some slack variable x 3. This is slack variable in order to make it equality sign. Then next is your 3 x 1 minus x 2 plus another new variable x 4 is a slack variable is equal to 25. Then third equation x 1 plus 6 x 2 plus x 5 another slack variables introduced in third equation to make equality sign. So, our problem is minimize this one and then subject to the constraint of this. So, there is a standard LP problem is now formulated. So, you have to solve this one, we know how to solve this one by what is called algebraic approach. So, first you identify which are the basic variables are there. Again, then you can see once you know the basic variables of this one, then there are 3 equations are there, 3 equations and you have a 5 variables are there. So, how many what is called that basic solution is exist that one can find out immediately. So, our n is equal to how many variables are there? 5 variables are there. How many equations are there? M is the number of equations 3. So, number of basic solution is equal to NCM. So, it is a factorial 5 divided by factorial 3 and this is a factorial 2. So, that will be a 10. So, 10 feasible basic solution is there, number of basic solution. So, now you see the way you want to solve it by a algebraic approach. So, you have to 3 basic variables are there and 2 are what is called non basic variables. So, you select 3 basic variables and find out the new vertex of the solution. Once you find out the vertex of the solution, find out the objective function below and once you find out then you check the what is called our extrema, you check whether you need further to change non basic variable to basic variable or not by computing R d transpose. If the elements of R d transpose contains negative terms, negative values, terms of values, then take the largest negative component of R d and corresponding non basic variable will enter as a basic variables and then you from the basic variables which variable will basic variable will enter as a non basic variable that you tested and repeat the process until unless you get that R d transpose all elements are positive. Once it is positive, it indicates further movement is not required to achieve the minimum value of the functions. So, this is let us see this one graphically, see what is that will make you more clear. So, let us call this is x 1 and this is x 2. Now, I am plotting these three equations. So, let us call first I am plotting g 1 of x. So, before that I am just putting 5, 10, 15, 20 and 25. Similarly, 5, 10, this is 15 and this is minus 5, minus 10, minus 15, minus 20 and minus 25. Five and let us go minus 10. So, let us call this equation I am plotting. Let us call this equal to 8.5. So, when x 1 is 0, when x 1 is 0, then x 2 value will be 8.5 divided by 0.6, that will be near about 14.2. So, 14.2 is here, 14.2. When x 2 is 0, when x 2 is 0, just you plot that one with equal to sign. When x 2 is equal to 0, that will coming near about 8.5 divided by 0.4, that will come near about 21.25. So, this is your equation, and since it is an inequality condition, this one is g 1 of x is equal to 0. Since the g 1 x is less than 0, then this indicates this is this region, all regions below this shaded one, this condition is satisfied. So, we also know the x 1 or x 2 is greater than 0, that means this quadrant, this whole quadrant x 2, and also know x 1 is greater than 0. So, it is only in the first quadrant of this one. So, this is our 0. So, this is our g 1. Now, see our g 2. Similarly, you plot g 2. So, if you plot g 2, then when x 1 is 0, x 2 is minus 25. So, it starts from minus 25, and then when x 2, you see when x 2 is 0, then it is a 8 point something. So, 8 point something means here. So, 8.33, let us call it is here. So, this is the straight line, and this line is g 2 of x is equal to 0 on the line. Any point on the line g 2 is 0, any point on the line this blue line is g 1 x is 0. So, since it is less than this, our region is that one. So, now you plot it what is called g 3. G 3 when x 1 is 0. So, x 2 will be 70 by 6, that near about 11 point something. So, this one is 11.66, 10, 11.66. So, this point is 11.66. Now, when x 2 is 0, then this is 70 divided by 3, 70 divided by 3. When x 2 is 0, 70 divided by 3. I am just plotting this one with equal to sign. So, 70 by T, this will be near about 20. So, this will be a so 70 by, so it will be a 70 by 3, 70 by 3 is 20, 70 by 3 is near about 23.33. So, this will be 23.33 somewhere here or somewhere here. So, on the line this is G 3 of x is equal to 0 on the line, and since it is less than this one, that region is that one. So, clearly from this one our feasible region is that one only. Any point on this one, any point on this shaded region, it satisfies the all constraints, but outside this it does not violate the any one of the constraint. Out of the 3 constraint it violates. So, our thing, this is the feasible region this. So, now according to the problem stated here, you see that this is our function, and we have to minimize this function. So, we know if you add some constant in an objective function and then you minimize this function, the what is called the optimum point will not change anything, but function value will change it, but optimum value of this variable, decision variable will not change. So, let us see our objective function, or let us say what are the feasible points are there. All basic solutions are there. What are the basic solutions are there? So, we have a this point, let us call this point is P 1, this point, then we consider this is P 2, this point is P 2, then we consider this point is P 3, and then we consider this point is P 4, and this point is your P 5, agree, and this point is P 6, and then this cross of this one is, let us call P 7, then this cross is P 8, this cuts is P 8, let us call this is P 8, P 8, and where it cross of that point is P 9, and this point is P 10. So, these are the basic solutions are there, agree. So, out of this basic solution you can easily realize from this figure that P 1, P 2, P 3, P 4, P 1, P 2, P 3, P 4 are the feasible solution. And remaining that P 5 to P 10, P 5 to P 10 are the infeasible solution, solutions. Now, let us say P 5. P 5 it does not satisfy, it satisfies only the G 1 conditions, but it does not satisfy the other condition G 2, G 3, G 2, G 3, it does not satisfy that one. It satisfies only G 1 and x 1 is greater than 0, x 2 is also greater than 0, but it does not satisfy G 1. Similarly, you can see other points also. Let us call P 6. P 6 also is satisfy the only G 1 conditions, but it does not satisfy other conditions. So, we may have in this particular problem that are what is called 10 basic solution are there. Out of 10, only 4, only these 4 P 1, P 2, P 3, P 4 are the feasible solution, and remaining points vertices of this one is P 5 to P 6, P 7, P 8, P 9 and P 10 are the infeasible solution. Now, see, if you change the sum of the constraint, let us call, if I just put, if G 1 of x is greater than equal to 8.5, that is our same thing, just only we have changed the inequality constraint, instead of less than equal greater than this, then our region of for G 1 will be above this one, above that one. So, we do not have at all any solution of this problem, because it violates all the points what we got the basic feasible basic solution, all points is violates, means we do not have any solution if we change the what is called the constraint with this type. This. Now, let us call what is the our what is called our minimum value of this function. So, our objective function, as we mentioned it, that our objective function is f x. If we add, our problem is f x, minimize the f x subject to this condition, and what point, what vertex this function will minimize. Same point, if you change the function by a constant, by adding a constant term with this function, it will also minimize the new objective function at the same point. That is, we have already discussed that if you add to the objective function some constant term, or if you add with the, if you multiply it by this thing with some constant factor. So, our optimal point will not change it. So, let us call our objective function was this one, that is given is minus 990 x 1 plus minus 900 x 2 minus 5250. So, now I am changing our new objective function is, we are telling our new objective function is f bar of x, which is nothing but a f of x plus 5250, that constant term we take in this one. So, that is minus 990 x 1 minus 900 x 2. So, graphically you see, so when x 1 is 0, x 2 is 0, the function value is 0. Agree? So, if you plot a line through 0 origin, this is f bar of x is equal to 0. Any point on this line is new objective function value is 0, means this one. If you move this new objective function up parallel with this one, f bar is equal to 0, up and down, the objective function value will decrease and increase. So, if you go up, agree, then objective function value is increased. If you go down, the objective function f bar value will decrease. Agree? Now, let us say if you go up, slowly you are going up parallel to the f bar of x, this dotted line, parallel to this dotted line. Agree? Then function value is go on increasing, but our problem is to minimize the function value. So, that will be the minimized value of the function f bar is 0 here. So, we can go below. Suppose if you go parallelly below this one, then let us call another, I am showing it parallel to this one is agree. So, the function value is decreased, f bar value is decreased, which in turn f also decrease, agree, but we have to see whether it is a feasible solution or not. So, any point below this line, any line parallel to this one, if you go downwards, then there that will not give you any feasible solution, because our feasible region is that one. Our feasible region is that one. So, let us call this corresponding to f bar of x is equal to this corresponding to f bar of x is equal to minus 5250 this, and corresponding value one can easily find out this corresponding the line corresponding to this one, but this value is increasing, I am sorry, decreasing, but any point on this line or anywhere in a, this is not the feasible solution. So, this solution though function value is decreased, but solution is not acceptable. So, our for this particular problem from graphical interpretation is that the point P 1 is the optimum value of the function at that value. That means, P bound value is x 1 is equal to 0, x 2 is 0, agree, and x 3, x 4, x 5 value we will get it correspondingly. That I am not just graphically I want to represent that what is this. So, I will just write you at P 1 point, at point P 1 we will get the minimum value of f bar of x, which implied f of x the and the corresponding value and the corresponding value is your minus 5250. You see this one f bar, what we have considered the f bar, just f bar we have considered the value of f bar here. See, the value of f bar is this is this is equal to 0. So, f of x is equal to minus this one is the optimum value of the function. So, the if you just recall that you will get unique solution if the objective function and the constant have dissimilar slopes. Unique solution if the objective function and the constant have dissimilar slopes, and there is a infinite solution if the objective function slope and if it is same as one of the constant, one of the slope of the constant equations or constant equation, then you will get a infinite number of solution. That means, same means parallel. If the objective function is parallel with the constraint of the subjected to the constraint, one of the constraint, then we have a infinite solution. So, this is our. So, if we recall all these things, first given the if you have given the problem, convert into standard LP problems. Then once you convert into the standard LP problem, then find out the its see its basic variable and non-basic variables, and you find out the objective function value at the initial vertex. Once you find out the objective function value, then you compute the RD transpose, which will give the indication whether if you change one of the non-basic variable to a basic variable and basic variable to a non-basic variable, whether function value will reduce further or not. That if it shows that the RD transpose, the elements of RD transpose having more than 2 negative numbers, then consider the largest negative component corresponding to the non-basic variable, that basic non-basic variable will treated as an basic variable for further iterations. And one of the basic variable you have to convert into a transfer entered, one of the basic variable will entered as a non-basic variable by following the test we have mentioned it. So, this is the summary of the problem, how LP problem is solved by algebraic approach, how it can be solved. So, this is we will stop here today.